Hi, welcome to another video and episode on my Raspberry Pi. Currently I only have Raspberry Pi 1 Model B Plus in function. I programmed it using wiring Pi to use pulse width modulation in order to get these motors running on Raspberry, and these motors are usually controlled by pulse width modulation. However, after programming it and setting up this circuit using an op amp and a pot meter for varying the voltages, it turns out that pulse width modulation has no influence at all, and the motor, especially this one, runs easily at a nice voltage of 9 to 12 volts. Now when I remove this wire, which is coming from directly from the RPI and provides 5 volts, everything stops, including this LED. When I take this one and this one is going, and let me follow the wire, is going here as well. So this one is there and this one is going there. It provides some voltage as well, so when I remove it, everything stops. Then this wire is coming from pin 12, and pin 12 is GPIO 18, which is the port enabled for pulse width modulation. So if that is indeed driving the motor, pulling the wire would be quite a difference. I pull the wire and there's no difference at all. So putting it back in place has no influence. Now there's one other point, that if I pull here from the op amp, the motor does run a little bit faster, and putting the wire back just slows it down a little, and that's quite weird. Another weird thing is that, let me readjust the camera a bit, that this motor doesn't do a thing anymore. I can turn the speed up and you will hear that the motor goes up, but now it does. But last time what also happened was that the voltage on this motor, which should be at least 9 volts, turned out to be just 1 volt, and I need to check that once again, because also this LED is not burning anymore. So that is the next step. In order to once again trying to measure the voltage over the second motor, which runs remarkably slower, considerably slower than this motor. I have put some probes on it, and let's show the voltage. And this voltage is not really constant. Let me turn it around a little bit. It is about 1.5, almost 1.5 volt. So that's quite weird. Now, what happens when I turn the pot meter? Let me show you. When I turn the pot meter fully up, and the only thing that happens then is a very slight upgoing needle to 1.5, which is in no comparison to the about 10 volts that is over this motor. So although this part does work, the pulse width modulation program is not running, which means that that is of no consequence. So that doesn't matter at all. But the fact that this motor is running on 1.5 volts is quite impressive. So let's turn it all down again. And see what happens. Very slowly up. There you go. Very slowly. And the multimeter, and now I have to take, yeah, and that is what happens when I take it off, because it lets go very easily. I don't like that. It runs not enough to have the LED burn, but the motor does work. And the multimeter is showing 0. Now I have enough for the LED. And then it's interesting to measure how much volt is on the LED. So let's do that. Measuring one here. Oops. That will be hard. Let me just hold it, and measuring here, which shows 4.5 volts. So apparently 4.5 volts is about the minimum that is 3.5 volts, but the LED is off, and 4.5 volts to have the LED burn. So that's one thing. And then let's take the second motor again. Oops, but it doesn't matter. That's 0 and it does not run. Let's aid the motor a little bit. Now it runs. And I release it too much. So probing again. And it shows just a half volt. So it's not what you call quite stable, but things do run. So the theory of pulse width modulation necessary is gone. Let's see what we can do further. So to once more show the program that in the end turns out not to be necessary. This is all as usual. If you've seen my previous subjects like LED play, etc. This is the new wiring PI. Wiring Pi, actually. PI is something else. Using namespace STD standard. It is not strictly necessary, but if I wouldn't do this, I would have to use STD double colon on quite a few places, and let's just keep this the way it is. Then GPIO 18. The only output on the, well, I think it's the only output on the GPIO that provides pulse width modulation, and you need wiring Pi to activate it. Otherwise, pin 12 or GPIO 18 is just another pin. Then let's look further. This code is commented out. This code is commented out because of this. So it is commented out because I don't need it for this program. By the way, in C++ and in C you use this to comment entire blocks out that are directly behind each other, and // is used to comment just one line. So, and here if wiring pi setup is not functioning okay, status -1, then just exit. While true, just keep running. And so you see it is quite a simple program. Here you see the output, instantiated, etc, etc. And this doesn't mean it doesn't work, because it's just what you print. And 18, let's show that 18 is exported actually. Here GPO 18 is exported, so it does work. And here set to output, which does work. And PMW write 1 256. What I may try, that would be an interesting thing, to change the 256 to 500. See what effect that will have. Let's just do that. Then I will have to compile. And that is not this one. Because I have to link in. Now, where is it? I can try if this actually does work. Yes, it does not work. So I need the other one. I need one with a link to include the wiring pi. Which I obviously can't find right now. So let me find that first. And that actually turned out to be quite easy. The compile command added with -L wiring pi did the job. So let's run it anyway. See if it has any consequences at all. So far So for no consequences at all, just the same working, unfortunately. So changing to 2024, I'm going to leave it as is. And maybe I can do a experiment where it has some use. Anyway, to clarify the program further, when I'm pressing Ctrl C, this is setting setting the pulse width modulation pin to 0, setting unexporting everything, deleting everything, deleting the instantiated objects, and that's about it. So what was this whole setup about? Not to use pulse width modulation per se, but to have motors run on the Raspberry Pi, because usually you have to use an H-bridge, and by using an op-amp over the whole setup, amplifying the 5 volts to apparently 10 volts, it operates the motor. However, as you could see on the multimeter, the voltage over the other motor is not even close to 5 volts. So the question remains, how can that one run? Does it need pulse width modulation? I can just off screen try that as well. So I'm removing that pin now, but the motor, the second motor, just keeps running. So we can easily state that has no consequences. Removing the 5 volts from the op-amp has consequences. It immediately stops the motor, both of them. So the op-amp is needed in case of this motor, and I can do that again to test it right. Oh, I'm wrong in that conclusion. I just removed it and it stopped the second motor, but it let the first motor run even faster. So that brings me to new experiments on the Raspberry Pi, and it's an idea to engage to the Raspberry Pi 2 again. So let's see how that works out. Alright, it took some efforts to get started on the Raspberry Pi 2 again, because I did this experiment entirely on the Raspberry Pi 1, so I had to install Wiring Pi via its own website, used Git for it, the copying software Git. I built it and I have that running. Also via my file server I had to copy the same software that proves as to be no use for now, but who knows whatever comes across, but I still have to compile it. So let's do that. This is one that I have to use. Then GPIO motor.cpp, and I want as an output GPIO motor, and that not forget I have to include wiring pi in linker, otherwise it won't compile. So let's see how this works out. Really? Full of surprises. So let's see which command I used here. GPIO.cpp I have to use. So that is what I will use then. There we go. Without any error this time. And this is one of the issues that I have different on the Raspberry Pi 1 and the Raspberry Pi 2, where I can do without sudo on the Raspberry Pi 1, I have to use sudo on the Raspberry Pi 2. Actually that's not entirely true, but in some cases I can. So let's do this. And there's absolutely no difference in behavior. So I guess this is it for experiment on a Raspberry Pi 2. It has some pulse width modulation stuff, exactly like the Raspberry Pi 1, but H-bridge or no H-bridge, which is the letter H, not the word H, by the way. Yeah, this is it for now, but I will continue searching for clues on motors and Raspberry Pi 1 or 2. So for now I can end this, and perhaps you can still hear the motors running. But for now, thank you for watching, and probably to be continued.